Before we proceed any further, let me warn you. I have a bad voice. I'm using a different system today because my system broke down and this is a small laptop with a small screen and it has been hacked to run SolidWorks. So you may see some glitches in between and finally there might be a lot of background noise. So sorry for that. Good morning, good afternoon, good evening everyone. It might be midnight for some of you. Well, welcome to the sixth edition of SolidWorks' largest user group meeting. SLUGME was the idea of and brainchild of Toad. We started it in 2016 and since then this meeting is being organized every year. Look at the stats from previous few meetings. You will find very interesting numbers over there. Before we dive into the presentation, let me give you a brief intro. I'm Deepak Gupta. I love helping people. I'm based in India. Yes, I'm real. A lot of people still do not believe that. A SolidWorks expert and champion. I have been learning SolidWorks since 2005 and still learning. I work with a lot of companies and users around the world to help them with their design, drafting, and automation needs in SolidWorks. So when we say automation, it's basically using macros standalones or add-ins inside SolidWorks to do repeated or complex tasks. Using these tools helps you to reduce the time as well as the errors. So basically, using these tools, you are telling SolidWorks to do the job automatically while you enjoy the break. I am one of the proud winner of Michel Pillars Award. It was awarded to me at SolidWorks World 2014. Let's discuss the agenda for today. Animation is one of the favorite tools in SolidWorks. Every day we see a lot of cool animations made by various users across the globe. Some of them are very simple and some of them are very complex. Using some simple tricks and techniques, one can make complex looking animation with ease while having fun creating them. So this is what we want to do today. We will have fun creating two of such animation and we'll also look at some of the other cool animations. The first animation we will make is of cutting the assembly while showing the inner details. We would need an assembly and a cutting plate to make the dish. Before we start the actual work, let's see the end result. This would make it interesting to see what we are going to cook. As you have seen, we were cutting the assembly showing the inner details while there was some motions inside the assembly. It may look a bit complex animation, but this is a very simple animation using a simple distance mate and a cutting plate. So let's see how to do it. You can use any assembly you want. I'm using gearbox assembly. This can be found under SolidWorks tutorials. To make it easier in selection, I have collected all the existing assembly mates into one folder. This is very helpful when you have to do changes to specific mates in the animation, so that make it cluster free. Now since we need to do the animation, make sure that motion manager is checked under user interface. We have our assembly ready. Now we need our cutting plate. So let's start a new part. You can do the sketch on any plane. I'm sketching it on the top plane. I'm using S key and a center rectangle with first or center point on the origin. You can give any dimension you want. I'm making a 100 by 50 rectangle. I'm done with the sketching, so I'll press D key to exit the sketch. This is the shortcut to accept and not accept. Now I want to extrude a plate, so I'll again press the S key. I'll set the extrude command, and with a default depth of 10 mm, I'm okay. I will press the D key again and accept it. So my plate is ready. I will save my plate and I'll name it cutting plate. We have the plate ready. So let's go back to the assembly. I will insert the cutting plate into the assembly. Place it anywhere you want. Now we will apply few mates between the cutting plate and the assembly. So first front plane to the front plane, a coincident mate. Then right plane to the right plane, again a coincident mate. Make sure the plate is free to move up and down. Now we will apply a third mate, which will be the top face of the plate and top face of the assembly. We will apply a distance mate with a value of 0. Make sure you check that when you increase the value of the distance mate, the plate is going down. If it is not going down, you can flip the dimension. And after making sure that yes, on increasing the dimension, it is going down, set the value back to 0. So our mating part is done. Now we need to do the secret part. Start a sketch on this cutting plate. Make sure it is on that cutting plate and not on the top face of the cover plate. Just for easification, we can hide this plate. Now again press the S key. Start a rectangle. I'm taking a corner rectangle with first point on origin and just dragging it down enough. You can take any values if you want. I'm just taking it 70. So you can take any values you want. Doesn't matter. Our sketch part is done. So let's exit the sketch. Come back to isometric view just for easification. And now I need to apply an extrude cut. So I'll press the S key. I have the extrude cut shortcut on my S key. Now you can see the preview. So make sure it is through all. We need to change the direction and make sure it is pointing upwards. Under feature scope, uncheck auto select and make sure that selected component is checked. Propagate features to part is unchecked. We can do a little zoom in to select the parts. So I want to cut this part, this screw, this plate, this body, and this plate. And once you have selected the desired part, you can click OK from here. You can click OK from here. You can press D key or you can right click and OK. Now to test and make sure that these details are working correctly, we will edit our mate. And as you can see, it is working correctly. So let's set the value back to 0 and close it out. So cutting plate has been positioned, cut extrude has been applied, required mates have been done. So let's go to the motion study to make our animation. We'll switch on to the motion study tab. We can expand the motion manager if required. We will drag bar to say 10 seconds. You can keep any time frame you want, like if you want to keep it for 20 seconds or if you want to keep it for 12 seconds. So let's keep it for 10 seconds. Now with the bar on 10 seconds, double click on the distance mate and change the value say to 130. Now you can see the cut has been done. Just to add some fun, what we will do is we can add a rotary motor to the shaft and this gear. So let's click on motor. Rotary motor is already selected. Click on the edge. If required, we can change the direction, and just with the default setting, we click OK. Now let's minimize or collapse motion manager and we hit on calculate. Calculate is basically rebuilding the animation or doing the calculations for the particular animation. Now we can just play it. So you have seen like how easier it was to use a very simple technique to create this complex looking animation, like where you are cutting part of the assembly and showing the inner details. So this is very useful when we are doing some presentation to the users, to the clients, or to your internal team. So while things are in motion, you can cut out or remove the outer items while showing the inner details, and you can do a reverse of it. Let's expand it back. I'm moving the time bar to 20 seconds now. Again, we will double click on the distance mate and it will show us the last value we have entered. I will simply put it 0. So now you can see, so basically from 0 we went to 130 to do a through all cut and then back to 0. So now let's minimize it and see the result. So the calculation it will start where it finished the calculation last time. That's why it started from the bottom. Now let's play it and see the complete animation. So you can see first it went down and then it went up or came back to its original location. The playback speed I had set to 0.5, but you can use any of the speed you want. Let's play it on 1x. This animation was showing the cutout being done in the linear way. So if you want to do it in a radial way, instead of using the distance mate, you will use the angle mate over there, and then you can control the angle from 0 to a certain degree and back to 0. I'll show you one finished animation where I've used the angle mate and rest of the technique was the same. So let's play this animation. Like I said, you can use the angle mate if you have to create a dynamic section in animation like this. So using both the distance mate or the angle mate, you can create dynamic sections in animation showing the inner details to your users, to your clients, or to your internal team. This is very helpful when showing some complex assemblies uh, and showing the inner details. Instead of hiding them, you can just cut off the outer parts while showing the inner details. So let's go to our second animation. This is again one of my favorite, a very simple though complex looking animation. In this, we would create both the parts and the assembly. We will be using in context modeling, and then again the favorite distance mate to do the animation. But before we go on to the creating the animation, let's play it. So the animation is looking like the ball is being pushed to this flexible pipe, and the pipe is being expanded to the shape of the ball. In reality or in SolidWorks, well, the pipe is not actually expanding. It's not that flexible material. So every model you make in SolidWorks or other CAD software, so they are not flexible. So they are rigid. But using some techniques and the animation, you can show that the models are flexible and they can expand or contract. So let's go back to SolidWorks to see how to make this animation and have fun. Okay, to make this animation we need two parts, the ball and the tube. So let's create the ball first. I will start a new part. I'll start a sketch on front plane. I'm using the S key to create a circle. Then again S key and a line to act as a center line. Then I will trim off the bottom part. Again S key to dimension it the radius of 30. Now the sketching is done. I will press D key to exit. Again S key and I will select, sorry for that, I will select the revolve command. I'll select the straight line and the horizontal line as my center line. As I have said, like this is a different machine, so I have turned off few of the options, and that's why we are not seeing any preview of the revolve. I'll select OK. The ball is ready. Let's save it. We can save it anywhere we want. I'm just creating a new folder to keep it organized. Now next we need the second part, which is the tube. We can either create an external tube component and then create an assembly, or we can also create one internal component inside the assembly. So both will serve us the same purpose. So let's go with an external one. So I will create a new part. I will start sketch on front plane. I will press S key to select a corner rectangle and just drag it anywhere. Now let's dimension it. So this is around, sorry, so this would be 25 mm, 50 mm away from the origin. The length is around, say, 400, and then we coincide origin with the bottom line. Our sketch is fully defined. Press the D key. OK. Now press the S key again. We need a revolve, so I will select revolve. I will select this line as my center line. You can see the preview, not the shaded preview. So let's click D and OK. I will change the color to green. We will save this tube now, so I'll name it as tube. Now we need the assembly, so let's create one assembly. I will start one assembly. I will insert the tube and as a first component, and that will make it fixed. Now I will insert the ball part. We don't want to keep the ball as first component because that will keep it fixed. We want the ball to move around. Now let's add the mates first. So front plane of ball with the front plane of assembly, coincident mate. Then top plane of the assembly and top plane of the ball, again a coincident mate. Now you can see, or you have to make sure that the ball is free to move vertically. Now let's add a distance made plane between right plane of the ball and right plane of the assembly. Like we did a check in our last assembly also, you have to make a check that when you increase the distance value, the ball is moving on to the right. So since it is moving to the left, we will flip the dimension, and now you can see it is going to the left, right, sorry. So I'll set the value back to 0. Okay. Our mates have been defined. So let's modify the tube part. Before we do any kind of modifications to the sketches, let's save this assembly. So I'll press Ctrl S and I will save assembly. You can give any name you want. Now let's modify the tube sketch. Expand the tube, expand the revolve feature. Now click on sketch. You can also do right click as well, and you select edit sketch. Now we will just, for easier selection, we will expand the ball, we'll expand the revolve, and we will make this sketch to show. Now we will go to convert entities, we will select the sketch and hit OK, and then we can hide the sketch. Now we will trim off the area, so I will press S, select the trim command, and now we can see trim has been done. Let's click OK. So you can see that after we made changes to the tube, the shape in the revolve, or there is a ring formed on the outer side of the tube. To make it look real, let's add some fillets. So I'll click the edge and then you can see the fillet command. I will select this edge also. If you want, you can increase the fillet. So we'll make it 20 and hit OK. Next, we will add the shell command. So I will go to the feature tree, select the shell, select this face, I will put the thickness 2. Make sure you select shell outwards, hit OK. So if you do the section, this is how it will look like. I will set it to front plane. I will start a new sketch on the front plane of the tube. You have to make sure that you are putting it on the front plane of the tube. Then you can just do 2 rectangles over there. I'm just going to position or add some important dimensions only, and rest we can leave. So this is, I have set it to 35, and this I'm putting as 100. It's always good to define your sketches, but we can leave that in this case. Now my sketch is done. I'll press D key. I'll press S. I will select Cut Extrude. You can select the through all from here, or you can right click and select through all both directions. We want to cut the tube on both sides, and we just hit OK. I'll remove out the section view, and this is how my tube look like. So the critical part with this animation is that the order in which we have done the sketch, the fillet, the shell, and finally the cut extrude. That is very important. Otherwise the feature may fail, and you may not get the desired result. So my tube modification is done. I can just edit it, just collapse it, and let's save the assembly. So make sure when you are working, you regularly save your files. Otherwise, sometimes like due to window crashing or some glitches in the software or some other things, you may lose your work. So it's always good to keep saving your work in the meantime. Now let's create our animation. So I will move on to the motion study tab. I will expand it out, take the bar to the 10-second. I will expand the mates. I will double click on the distance mate and set the value to 290. We can collapse it and then can hit the calculate. Now let's play it. As you have seen, creating this animation was very simple, though the animation was looking little complex because of the shape changes, a continuous shape change in the tube. But using the trick and the in-context modeling and the distance made, we made this complex assembly just like a child play. Let's look at other animations and see how we can do some of them. The SLUGME flag. In this animation, we will see our flag waving. This is again a very complex looking animation, yet it is very simple. But first, let's see the animation in action. I will play it. Let's go back to SolidWorks to see how to make this animation. Now let's create our flag assembly. So we'll start with the flag part first. I will start a new part by pressing Ctrl N. So without doing anything, we will save this file. I will create a new folder and I'll name it as flag. Now we will create the rotor part. So I'll press Ctrl N again and a new part. I will start a sketch on right plane. This is very important for this animation. I'll press S key and select a circle with center point on the origin. Now again S key to dimension and I will set the diameter as 25. Now the sketch is ready and we need to create one helix out of it. So while in the sketching mode itself, I will go to the feature command tab, go to the curves and select helix. If it is not visible or available on your command manager, you can also go to insert, curve and select helix spiral from there. So by default, SolidWorks give you some preview depending on what was used last. I will change the definition to height and pitch. I will set the parameter as variable pitch. Now let's define the parameter. So for the first row, I will define the pitch as 500 mm. For the second row, I will define height as 700, pitch as 1000 and diameter as 250. For the third row, I will define height as 1800 mm, I will keep the pitch same 1000 and I will change the diameter to 400. Make sure the start angle is 0 and now we can click OK. So you can see our spiral is ready. Next we need to create one axis. So I will select front and top plane, go to the reference geometry and select axis. So you can see a preview of the axis. I'll hit OK. We can set the axis to show by clicking on the view axis. Now we'll save the file as a router. Now we need to create one assembly, so I will press Ctrl N again and double click on the assembly icon. I will select the flag and click OK. So the flag will come as a fixed part. Now I will insert the rotor and leave it anywhere because we need to define it. So the mates are very critical in this. So I will select right plane of the rotor, right plane of the assembly and coincident. Now we need to select the axis, start a mate, and now we will be doing multi-mate. So let's see. So in one mate itself, we are defining the two mates. So basically the purpose of these mates is to make sure that our curve is rotating along the horizontal axis while remaining fixed or for any kind of movement in other axis. Now let's save our assembly. I will press Ctrl S, save the assembly as flag assembly. We will edit our flag part now. So I will go to the flag. I will set it to edit mode. I will start a sketch on the top plane. Select this curve and press convert entities and hit OK. We can hide this curve. We'll now start a sketch on the right plane. I'll press the S key, select the midpoint line, just draw it anywhere, select the midpoint and make sure it is not on the origin but on this point. We will give a dimension, say 1200, and we also make sure that line is vertical. So you can see the color has changed to black, which means it is fully defined. I press the D key to accept it. Now I will start a 3D sketch. Again S key, option will be midpoint line. I will select this point and along the y-axis I will create a line. I'll select this line, I'll select this line and set them to equal. So sketching part is done. I'll press this sketching part is done, so I'll press the D key and exit the sketch. Now I will go to surfaces. I will select loft. So last sketch is already selected. Now I select this line. So you can see a preview over there. For the guide curves, I will select the shape. So you can see our flag is ready. Now let's wave it. So I will exit the edit part mode. Our assembly is ready. Now let's make the animation. I'll go to motion study tab, and since we do not need to make any changes to the mate, I will not expand it. I will simply click on the motor. Make sure rotary motor is selected. I will select the axis which we created in the rotor part. I will set the speed as 15 and click OK. And now let's calculate. And let's play. When you add a motor, so by default SolidWorks creates an animation or motion of 5 seconds. So if you want to increase it, expand the motion manager, drag the time bar to say 10 seconds, drag the key to the 10 second, and you can either calculate or play. So you can see that this might have looked a little complex animation, but using the simple trick of in context modeling and a rotary motor, we created this wonderful animation. Now let's go back to our presentation to see what other animations we can look at. This is again one of my animation made using in context modeling and the distance mate. So let's play it. Idea of showing this video clip was to give you an idea that what kind of animations we can do, though they look a little complex, but they are very simple, as you have seen in the last 3 animations which we have created. And I believe from the sessions you will have learned a lot of things, and now you will be creating a lot of cool animations which we would love to see. Before we take off this presentation, I would like to mention like where you can find me out. I'm one of the member of SolidWorks 3D Experience user community, so you can find me over there. I'm the slogan leader of Tri-City SolidWorks user group. This is based in Chandigarh. And the user group is based in Chandigarh, but it caters to Chandigarh, Panchkula, and Mohali users. On LinkedIn, you can find it me by the name of Gupta9665. The same handle is on the Twitter. On Facebook, you can find me by Boxer9665. On Reddit, you can find me by Gupta9665 handle. So with that, I will hand over the presentation back to the SLUGME team to take it forward. Thank you for your time.